This is a short video which emphasizes the need for the value of being creative when it comes to problem solving. It's a video on stacks and files. When we are first introduced to data structures, we learn of the stack, and the most compact way to house a stack is in an array. So consecutive locations contain this consecutive elements of a stack. Now, the behavior of a file is very similar to that of a stack in that a file always grows or shrinks from only one end. Now when it comes to a stack, we know that if we need two stacks, we can house them in a single array by placing them at the opposite end so they can grow into each other. This way, the common area can be used as necessary by either stack, whichever needs to grow more as required by the application. Now, the thought would have most likely occurred to everybody that can we increase the number of stacks, say, to 3, with still maintaining this property that each of the 3 stacks can equally grow into the other's area. Before continuing, if you wish to ponder over this problem yourself, you can pause it or stop the video. But the solution is a very simple one. Actually, it can be generalized to any number of stacks. The solution is simple. For 3 stacks, what we have to do is we have to not think of the memory as being organized in the form of a line or an array, but think of memory as being organized in the form of a triangle. Okay, now let's take the center. Now all the points in this, you can imagine something like an array here. So you can have a simple convention for numbering the locations, which is easily done. We think of the triangle as A, B, C. Now the memory is no longer an array in the sense of a line, even though it is physically an array only. But logically, you can imagine it as in the form of a triangle. Now you can have to house all the 3 stacks at 3. Take the center of each side. Okay, so now logically we can say these are all the 3 stacks here, bottom of each stack, and each grows to say one end or the like this way to the top, whichever side. So now this area would be the common area. So each can grow into the common area and into the other's area as well. So this way, if we organize the memory, not think of memory as a linear organization, which we are sort of constrained to do. It's like we are put, you can think of it only in one direction. Rather, you have to be a little bit more creative and think of memory as being organized. Now it is possible for you to house 3 stacks in an array only, with each stack growing into the other's possibility of each stack going into the other's area location as necessary. Similarly, if we want to extend this number of stacks to 4, we will have to think of the memory logically as being, even though physically it is probably only an array, logically as being in the form of a square. So each of the 4 corners will represent each of the 4 stacks or each of the 4 files, since the behavior of a file is similar to. So as the number of stacks or number of files increases, so for the 5 files or 5 stacks, the figure will be, you have to imagine the memory as being organized in the form of a pentagon. As the number of stacks or files increases, this figure will come closer and closer to that of a circle. So more or less, you can say that the logical organization of data in the form of a file, files on a disk, more or less corresponds to a physical organization on a disk. If the memory is you're storing the files on as a disk, then it is the same as that of a circular organization only. So this here where the so this is one of the ways you can organize or store data, store files on a disk.